Hello, you class. We're definitely missing you at school, the year sixes and I. Well, those who are still working from home, I thought I'd need to give you a little bit of help today, for this week, because I have no video links. So I'm making this one video, and I will go through different sections of the work with you that you're going to encounter this week, all on the one video, so you can pause it, then play it the next day, or if you think you're fine, you don't need to watch. Anyway, so we're going to start by looking at our first part of the lesson, which is, well, our Monday's lesson is looking at inverses and missing number problems. So first of all, I'm going to demonstrate how to put in some solutions for a fact family. Some of you might not remember that. And then I'm going to look at where you have been given a problem and you have to work out what the original number was, a bit like algebra, but early steps algebra. Okay, so I'm going to now move to show you my screen. You've got something a little bit similar to this. So I've got some Multilink here that represents an array, and I've got to come up with all the different facts that I can derive from this. So I know that I'm going to have two multiplication statements, because obviously multiplication you can do the inverse, and again two division. So looking what this actually represents is 3 times 4. So bear with me, I'm going to try and do this at the same time as recording. So sorry if my screen goes strange. I still haven't bought a tripod. Right, so 3 times 4 is 12. And now I need to do my inverse. 4 times, not doing very well with my writing either. 3 is 12. And now I need to do my division, which will be 12 divided by 4 is 3, and then the other fact, which is 12 divided by 3 is 4. So that's how you do the first one. So good old whiteboard for this one. So your last question, I think you'll be fine with the other questions. So the last questions look at being able to come up with the missing number. And this is like a working backwards problem. So it says, I think of a number. So that's your missing box, mystery number. I multiply it by 3 and then subtract 5. And I get an answer of 16. What was the number I thought of? So for this, when you're doing a solution like this, you need to work backwards. But when you're working backwards, do the inverse. So instead of take away 5, you're going to add. So 16 add 5 is 21. And then you do the inverse of times. So 21 divided by 3 equals 7. And then you just check it out. 7 times, sorry, that's not very neat. 7 times 3 is 21. Take away 5, and that is 16. So good luck with Monday's tasks. Right, so Tuesday is all about multiplication, multiplying by 2 digits. So just a reminder, if you need to, how would you approach this? 324 times 78. So we're going to go 4 times 8, because we're going to do 324, all of that times the 8 first. So 4 times, you can cover the 7 if it helps, otherwise just ignore it. 4 times 8 is 32. So I put down my 2, carry my 3. Now I've got 2 8s is 16. Add to the 3 is 19. So the 9 goes down and I carry the one next to it. And now I've got 3 8s are 24. 3 8s are 24 plus that one is 25. Right, now I'm going to the next line. So I'm timesing 324 times 70. Now because I'm timesing by 70, which is a multiple of 10, I know to put my 0 down there. It's obviously going to end on a 0 if you say 324 times 70. So again, cover up the 8 if you need to. 4 times 7 is 28, so I put my 8 down, carry my 2. 2 times 7 is 14. Then I add my 2, so I've got 16, carry. And now 3 times 7 is 21, plus this one, 22. Now I've got to add these two together as I'd normally add, so ignore these carries. 2 add 0 is 2, 9 add 8 is 17, so my 1 I carry down there, and my 7 goes there. 5 add 6 is 11, plus this one is 12. I carry my 1 and my 2 goes there. 2 add 2 is 4, add the 1 is 5. And then 2 add nothing is 2. So that hopefully is a good reminder for you, and good luck with your multiplications. I'm now going to show you a multiplication that's got some missing digits. So we'll have a look at that one. Now I've got my missing digit in a multiplication calculation here. I've got Teddy has spilt some paint on his calculation. What are the missing digits? So first of all, I'm going to find out this missing digit. So I've got 9 times something, ends on a 2, and I can see I've got the carry 7. So that must be 9 times something is 72. So that definitely is an 8. 9 8s are 72. So the next one I need to move on to, well, let's do the next one just to check. So 6 8s are 48, plus my 7 is 55. So that works. And now I've got this one times by my 8, and I know it equals 69, except I need to take off that 5. So 69, subtract the 5, gives me 64. So what times 8 is 64? It must be 8. So these two are 8s. Now let's move to this one. So I'm into my second part of my calculation. So this must be 0. Then 9 times 2 is 18. So this is also an 8. And that would carry the 1 over there. So that works nicely. And my final splat I need to sort out is this splat. So when I added here, 7 add 2, I got 9. But I had the carry from this one, the 1, which they carry here, but we carry underneath. That gives you 10, which means that would carry over there. So then this would be 5 add 2, which is 7, but add your 1 gives you 8. So actually they were all 8s. That's what I notice. We're on to division now, which is Wednesday's work. So we've got short division, 4 digits by 1 digit. We've also got this represented in place value counters here, just so that you understand what I'm doing. So we've got 9 divided by 3, so I can make 3 groups of that. So I've obviously got a 3 there. Just trying to get there, right, 3. So nothing to carry over because that was exactly 3. Now I'm looking here to make another group of 3. I can make 1 group of 3 there. So 1 group of 3, so that goes 1. But I've obviously got this 100 left over. So if I'm doing it in my short division, I would carry that 1 over here and I'd write 1 next to this 1, so making that 11. What is actually happening there is that 100 is being exchanged for 10 tens. So now I've got 10 tens plus this one, I've got 11 tens. 11 tens divided by 3. So 11 divided by 3 is again 3. But now 3 3s are 9, so I could group those 9, but I'd have the 2 left over. So I'd have my 2 left over, and if I'm doing my short division, I would write it there next to the 4. So I'd have 24 there. What is actually happening is my 2 10s left over get exchanged for 1s. So if I've got 10, 20 ones plus my 4, I've got 24 ones. So now I've got 24 divided by 3, which goes 8 times. So that hopefully has refreshed your memory about division, and then I'm going to just go do a quick explanation of the work on dividing using factors. So I've got now a 2-digit number. I'm dividing by a 2-digit number, but I'm going to use factors to help me divide. This obviously won't work with a prime number because it only has 1 in itself, but every time it's not a prime number, you could use this approach, especially with a 2-digit number. So first of all, I need to work out my factors of 14. So 2 times 7 make 14. Now knowing that, I can now go 280 divided by 2 is 140. And then I can take that answer and divide by my other factor. So 140 divided by 7. I know 7 goes into 14 twice, so that would be 20. And so I have divided using factors. Let's take a look at a little slightly harder one. Right, so I've got 1305 divided by 15. So I need to come up with some factors. So I'm going to choose 5 and 3 as my factors. So I'm first going to do, I think we'll divide by 5. So I'm going to do 1305 divided by 5, right? So 5 into 13 goes twice, remainder the 3. 5 into 30 goes 6, and 5 into 5 goes 1. So that's 261. Now I take the 261 and I now divide by the 3. So 3 into 26, that will go 8 threes of 24, remainder 2. 3 into 21 goes 7, so my final answer is 87. That's the very last thing I'm going to show you is for Friday's work on squared and cubes. Just remind you that 2 squared is 2 times 2. If I have to represent that, I would represent that as a square. Sorry, that's not a very good square. 2 times 2. If I had 2 cubed, I'm going 2 times 2 times 2. It's a cube, represented by a cube. Which equals, that equals 4, and this one equals 8. And I think you'll be fine with that task. So we're just going over something we've done earlier in the year. Oh, so thank you, Year 5s and 6s working from home, and hope to hear from you soon. Bye-bye.